Hi everyone, this is Mrs. G.A. and today we're going to learn about sine, cosine, and tangent ratios. So let's consider a right triangle, triangle ABC. One thing really quick, notice that all of the angles are uppercase and the sides are lowercase. And notice that if you look opposite, uppercase A is lowercase a. So that's how you name the sides. There are three trigonometric ratios that we're going to learn about. They're called sine, cosine, and tangent. So these three ratios have a definition based on the relative sides of the triangle. For sine, sine is always going to be the length of the opposite side to your angle over the hypotenuse. So one thing we can always do, if you draw an arrow across from your 90-degree angle, this will always be your hypotenuse. That's how you can always find it. So again, the sine is the opposite side length over the hypotenuse. Now, this is going to depend on which angle we're working with. So if we are finding the sine of angle A, notice I still read it sine even though it's the abbreviated version SIN. So the sine of angle A, if I'm starting here, well, we know the hypotenuse is side C, so we can write that in. But we have to determine which side is opposite angle A. And opposite means across from, so it's going to be side A. However, so that sine ratio is A over C. However, if we're working with angle B and I want to find the sine of angle B, I have to start here. And the side that is opposite angle B is side B. So this ratio is actually B over C. So your ratio is going to depend on which angle you are working with, and we will never be working with the 90-degree angle. Now, by definition, the cosine ratio is adjacent side length. Remember, adjacent means next to or touching, and then over the hypotenuse. So again, if we're doing cosine of angle A, of course, C is still going to be my hypotenuse, so that will be the denominator. But now I want the adjacent side. So the side that is touching angle A is side B. So it's actually B over C for my cosine ratio. Now if I'm doing the cosine of angle B, again the hypotenuse is going to be C, but the side that is adjacent to angle B is actually side A. So again, it's adjacent over hypotenuse. The last ratio we're going to learn about is called tangent. So by definition, tangent is the length of the opposite side over the length of the adjacent side. So for the tangent of angle A, the opposite side of angle A is side A, and the adjacent side is side B. So that ratio is A over B. Now if I'm finding the tangent of B, again I start here, opposite is B, adjacent is A, so this one is B over A. So there is something that you can use to help you memorize what each of these ratios represent. It's something you'll hear a lot of people say. It's called SOHCAHTOA. So we'll say the phrase SOHCAHTOA all the time. What these 9 letters stand for is sine is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, tangent is opposite over adjacent. So you can use SOHCAHTOA to help you memorize what these 3 ratios stand for. Okay, so we are going to start by using trig ratios to help us find missing sides. So let's start here with example A. So whenever I'm given a triangle like this, I want to look at the side that I'm given first, and I would like to label it in reference to the angle that I'm given. So since I'm given angle 68, this side is opposite my angle. So this is opposite, and of course the side that I'm trying to find is the hypotenuse. because it's across from our 90-degree angle. So then I look and I say, which trig ratio uses opposite and hypotenuse? And I know that would be sine. So we do sine of 68 degrees equals the opposite, which is 11, over the hypotenuse, which is x. So here we are solving for x. So if I'm solving for x, the next thing I'm going to do is multiply both sides by x. So it's no longer in our denominator. So x times the sine of 68 degrees equals 11. And again, I want to solve for x, so we're going to divide both sides by the sine of 68. This whole expression travels together. It's one single expression. So x is going to be 11 divided by the sine of 68 degrees. Now, this is something that you can plug into your calculator exactly as you see it. You just type in 11 divided by the sine of 68. You should make sure that your calculator is in degrees because there are other units for angles. And then we can do a decimal approximation for that side. So we get x equals 11.9. So by using the sine ratio, we were able to find a missing side. Again, with the information we have, even though it's a right triangle, we wouldn't be able to do Pythagorean theorem because you need at least two sides to do that. So this, using trig ratios, is a great way to find missing sides. Okay, let's look at this next example. Again, in reference to the angle we're working with, this angle 51 degrees, if I look across from it, I see x. This would be the opposite side. And then this is our hypotenuse, so this must be the adjacent side. So then I ask myself, which trig ratio uses opposite and adjacent? And that would be tangent. So we know that the tangent of 51 degrees, tangent is by definition opposite over adjacent. So we just say x over 20. And since we are solving for x, we're going to multiply both sides by 20. So we get x equals 20 times the tangent of 51 degrees. And again, this is something we can plug into our calculator to get a decimal approximation. So x equals 24.7. Okay, let's try another example. So again, if I'm using this angle, I see this would be called the adjacent side because it's touching our angle. And then this is our hypotenuse because it is opposite our 90-degree angle. So then look at what words you wrote and ask yourself, which trig ratio uses adjacent and hypotenuse? And that would be cosine. So the cosine of 42 degrees, cosine is always adjacent over hypotenuse. So we write x over 14. And then to solve for x, we're going to multiply both sides by 14. We get x equals 14 times the cosine of 42 degrees. Let's use our calculator to get a decimal approximation. Here we get 10.4. Okay, let's look at example D. Again, look at the angle we're working with. In reference to this angle, x, this side, is across the triangle, so that would be the opposite side. And 11 is opposite the 90, so this is always the hypotenuse. So we ask, which trig ratio uses opposite and hypotenuse? And that would be sine. Sine of an angle is always the opposite over the hypotenuse, so x over 11. And then we can multiply both sides by 11 to solve for x. X equals 11 times the sine of 22 degrees. Plug that into your calculator to get a decimal approximation. That side length x is approximately 4.1. Okay, so now that we know how to use our trig functions to find missing side lengths, now we're going to talk about how we can use trig functions to find missing angles. So when we need to find the measure of an angle of a right triangle, we use what are called our inverse trig functions. So our inverse trig functions are arcsine, which is denoted with this symbol. It looks like it's saying sine to the power of -1. We read this as arcsine. It stands for the inverse of sine. Next one is arccosine, which we write like this, and arctangent, which we write like this. So here's how we can use our inverse trig functions. So let's say we're able to set up our ratio. Sine of, this is the Greek letter theta. Maybe make a note of this if you need to. It's a really common variable that we use to represent angles. So the sine of theta equals 1/2. But again, if we're trying to solve for theta, we need to use our inverse trig function. So what you do is you swap the angle and the value, and then we turn it to an inverse trig function. So we actually would say arcsine of 1/2 equals theta. So again, notice now theta is on the outside, 1/2, the value is on the inside, and now it's our inverse trig function, arcsine. Now this is a button that your calculator has. So once you've done this, all you need to do is plug it into your calculator, and your calculator will tell you what the angle is. So I do want to make sure we can find these buttons on the calculator. They're a little bit hard to find, and this picture is very hard to see, but on a normal TI scientific calculator like this, this is our sine button, this is cosine, and this is tangent. So there's little numbers that are, or sometimes there's little words that are above your button. So actually, if you look right above the sine button, you'll see arcsine. If you look above cosine, it says arccosine, and the same for tangent. So the way that you write that or make that show up in your calculator is you actually have to hit the second button, which on some calculators it says shift. So if you hit second and then sine, it will make arcsine appear. So same thing, you do second and cosine to get arccosine, and then second and tangent to get arctangent. So I know the quality of this picture is a little bit bad, but it should be about the same on any scientific calculator. The inverse trig functions are usually above the original trig functions. Okay, so now let's see if we can use our inverse trig functions to help us find a missing angle. So we'll see how useful these can be. So again, this is the angle we're trying to find. So we're still going to try to label the sides appropriately. So I know this is my hypotenuse right here. So that means that this, the other side that's touching my angle, this would be the adjacent side. And this is the opposite side because it's across from my angle. So I'm still going to set up our trig ratio. So I say, what uses opposite and adjacent? And that answer is tangent. So this time we say tangent of theta, because we don't know what this angle is, equals, so by definition, tangent is opposite over adjacent. So we say equals 29/17. Now remember, anytime we're trying to solve for the angle, we have to swap and use our inverse trig function. So this now becomes arctangent of 29/17 equals theta. And now we can use the arctangent button on our calculator, and it will tell us what theta is. So our calculator tells us that theta is approximately 59.6 degrees. So remember, swap the values, the value with the angle, and then use your inverse trig function. Okay, let's try example B. So again, this is the angle we're trying to find. I can see that this is the hypotenuse because it's across from our 90-degree angle. And this side length is touching our angle, so we would call it the adjacent side. So we ask ourselves, which trig function uses adjacent and hypotenuse? So that would be cosine. So we say cosine of the angle theta, we don't know it. Cosine is adjacent over hypotenuse, so it's equal to 41 over 51. To solve for the angle, we're going to swap theta and this value, and then we use arc cosine, our inverse function, equals theta. And now we can use our inverse trig function. We can use arc cosine on our calculator, and our calculator will give us the decimal approximation of 36.5 degrees. Again, make sure you are writing degrees in your answer because there are other measurements for angles that you might use. Okay, for this last example, here's the angle we're trying to find. So let's label our sides. I see that the side length 3 is across from the angle, so we would call this the opposite side. This side length is across from our 90, so we call it the hypotenuse. And then we ask ourselves which trig ratio uses opposite and hypotenuse, and that would be sine. So we say sine of theta, which is what we're trying to find. Sine is opposite over hypotenuse, so 3 over 11. To find the angle, we do our swap, and then we use arc sine. So the arc sine of 3 over 11 equals theta. And then we can use our calculator to get the decimal approximation. Theta is approximately 15.8 degrees. Okay, that is all for today's video. Thank you so much for watching.